I wanted to show you an example of a Delta Math one that is integration by parts, but they call it function notation, just so that when you see it and it asks to do something, you've done one together, or at least you've watched me do this one. So here's one where they basically are really generic. They're giving you an F function, they're giving you a G function, they're giving you a table of information. They're asking you, this is what they're actually asking you to do, is integrate from 0 to 3 of g times f prime, but then they give you other information about what we know about the integral of g prime f and what we know about the integral of gf. And then you kind of have to put together what and all this information do you actually need. So first we're going to start with the given integral here and write down our parts. So our u, our du, our dv, and our v. So u is going to be g because we can derive it to get g prime. And then dv is going to be f prime because we can integrate it and get f. You may find actually after you see a couple of these that you actually like these better because you're not having to remember a bunch of derivative and integral rules and adjustments and all of those things. Keeping it generic in some way actually simplifies it. So now the process of integration by parts is these two multiplied together. So you get g of x, f of x, minus the integral of these two together, g prime of x, f of x. And keep in mind that the boundaries don't change. It's still 0 to 3. So this is actually known information. We know from this piece of information, we know the integral from 0 to 3 of g prime f is -1. So you're going to have a minus 1. So it's going to end up being plus 1 for that whole piece. This piece of information, this piece right here, we actually never use. It's one of those distractors. So now we have to take this first part, GF, and figure out what happens as we go from 0 to 3. Oops, sorry. So now that's where the table comes in. So this is a fundamental theorem, top minus bottom. So first you're going to put 3 into the G times F. So G of 3 is here. Oh, I lost my pen. Hold on. So G of 3 is -4. So -4. F of 3 is -6, so you have -4 minus negative, or times -6, and then minus what you get when you put 0 in. So g of 0 is -4 again. F of 0 is 2. So you end up getting 24 minus a minus would be plus 8, which is 32, plus the one that's been hanging out here that we knew. So your answer for this is 33. So I just want to take a quick second just so you see that. Nothing that I did in the regular notes showed you an example of it, but it's kind of an interesting way to do integration by parts in a very generic, they call it function notation. I always call it generic notation. So there you go.